Back in July, we launched a new breed of SOLIDWORKS called 3D Experience SOLIDWORKS. And it's really awesome. Well, why, you ask? Because our team wanted to get rid of files. After all, who needs to worry about files anymore? Since I'm connected to the platform and always in sync with seamless integration, it's like SOLIDWORKS and Cloud PLM all in one. So it's bold. Let's check out a quick overview. This is the product that we're going to be highlighting by Square Robot that we were discussing during this presentation. The 3D Experience platform is revolutionary, and not only in the sheer depth and breadth of its technology, but in the way that it can transform your business. It connects people so that they can collaborate on projects effectively together. It connects your data to advanced tools so you can make informed decisions on your designs. And it connects your team to powerful browser-based design applications, reducing the need for costly hardware. If you are curious about the data management and collaboration tools, then stick around. As we kick off SOLIDWORKS 2021 Part 3, we will dig deeper into how those tools by Innovia are gaining popularity with a lot of SOLIDWORKS users looking for their cloud-based solution. So wherever you spend your day, whether it's on parts, assemblies, drawings, or PDM, we hope you saw some compelling enhancements yesterday that get you excited to upgrade. So as a reminder, Service Pack 0 was released yesterday. So download your update and start using SOLIDWORKS 2021. During this presentation, I'm gonna actually serve the role and go over a design process, and I'm going to play the role of different individuals. The first person we're going to talk about is Mr. Eric. He's an engineer. We'll begin by dropping in on Eric, the engineer, as he starts his working day in SOLIDWORKS desktop. He receives a notification from his manager, Megan. Clicking the pop-up opens his 3D Swim app where he sees a discussion thread involving a new design request. He's being asked to add rollers to an existing assembly. He initiates a search, and for the related CAD model, he drags it into his SOLIDWORKS session. It's just that simple to access his SOLIDWORKS data that's securely stored in the 3D Experience platform. He reserves the assembly to give himself right access. Reserve is like taking ownership of a model when you're using like PDM or some other vault system. He made his design changes, but before saving back to the cloud, he wants to know where this assembly is used. The Relations app gives him a graphical view of all the parent-child dependencies. He finds the top-level assembly and opens it right in this session. He sees the familiar options to open the model in Resolved, Lightweight, or in Large Design Review mode. Choosing Lightweight means SOLIDWORKS doesn't have to download every part contained in the assembly. That's a big time saver for the large models Eric usually works with. With the top-level assembly up to date, he reserves it and clicks Save. When you save, in the 3D Experience platform, that's how you add files to the cloud. Eric creates a new revision of the lid now that the rollers have been added. Despite this being a pretty large assembly, saving time is efficient because only the models that have changed need to be saved to the cloud. But that was easy. In fact, his team was productive from day one because connecting their data to the cloud required no customization. So back to Eric. This time, Eric grabs his iPad and he takes off. All his 3D Experience apps are accessible from any browser. And with his data safely in the cloud, he has the freedom and mobility to keep working from just about anywhere on any device. He loads the top-level assembly into the Product Structure Explorer. This app provides a graphical view and a list view at the same time. He can arrange and filter the display any way he likes. So this entire scene here is a dashboard, and there's a tab called Product Structure. He needs to locate the newly added roller assembly within the structure in order to attach a supporting document. In this case, a PDF with installation instructions. Now it's time to give Megan an update of his progress. Instead of an email, a phone call, or web meeting, Eric tailors his interactive dashboard that will have exactly the information he wants her to review. First, he adds a 3D Play viewing app and preloads it with the top-level assembly. He also grabs a screenshot he can post back to the discussion thread. Next, he launches the Bookmark app, which is a convenient way of organizing shortcuts to frequently used or favorite items. His manager, Megan, likes this because it keeps her most important data right at her fingertips. When he's ready to share the dashboard, he just copies the link. As the last step, Eric opens his 3D Swim app in the side panel. He adds a comment, pastes the link to the shared dashboard, and inserts a screenshot of the latest design. Connecting SOLIDWORKS to the 3D Experience platform is the best of both worlds, cloud and desktop. Be productive right away with secure cloud data management. It provides a fast and easy way to store, manage, and share design data with the convenience and security of the cloud. There's little to no setup required, so users can be productive right away. Under streamlining collaboration, the 3D Experience platform is much more than just sharing SOLIDWORKS data to the cloud. For non-CAD users like Megan, the engineering manager, the platform gives her a simple browser-based approach to managing her team more effectively. Let's see how she uses the 3D Experience platform app to streamline collaboration. Megan opens her browser and sees Eric has replied to her post. He's included a link that she can add to her existing dashboard. The 3D Play Viewing app and Bookmark app are preloaded with the data Megan needs to review his latest change. Fully interactive viewing and even large 3D models is a breeze on any device, especially touchscreens. There's no special hardware required and no CAD license needed. Megan uses a measuring tool to verify the proper radius of the wall roller assembly. Oops, wrong units. The 25-inch radius is confirmed, but looking closer at the roller arms, she wonders if there might be excessive twisting without some kind of support member between them. So she launches the Issue 3D app to log a record of the issue. It's just one of many ways the team could use Innovier to track problem reports or change requests. She tags the related 3D models and verifies that the right people are assigned to the issue. In this case, Eric will be automatically notified through the platform. There's no need to follow up with an email or phone call. It's such a more streamlined way to collaborate. Now she launches the 3D markup. This app gives her extended tools to document the issue. She can create multiple views and add various annotations right on the 3D model. The markup and all other relevant information is self-contained within the issue and available to all stakeholders. While Eric gets to work on the design issue, Megan has a job for Debbie the designer. She uses the Collaborative Task app to assign Debbie with adding a hardware kit and creating a new drawing for the real roller assembly. Just like with the Issues app, Collaborative Tasks collect all the communication, assignees, and 3D model data in one spot and displays the progress of all her tasks in a single dashboard tab, giving Megan an overview of everything on her radar. And what you see before you is a column that shows what's to do, in work, which means that something is in progress, and when it's completed. Seamless collaboration with lighter hardware and less IT overhead. The 3D Experience platform helps Megan streamline collaboration with her team, all from a browser on any device with no software to install. The intuitive app eliminates dozens of other disconnected solutions, improving productivity and providing clearer focus for her team members. Solving design challenges together, the customer needs a quick response, so Megan's design team will need to work on the same SOLIDWORKS model at the same time. Not having the proper write access, accidentally overwriting someone else's work, these things happen all the time with traditional file-based data management. And it's even harder when workers are remote. Let's see how 3D Experience platform enables a more seamless, error-free approach to concurrent design. First, let's check in on Debbie. She has the Collaborative Task app running inside her SOLIDWORKS task pane. She sees the task that has been assigned to her and drags it to in work. The related CAD model is already attached. She just needs to open it in her session. All of Debbie's changes occur at the assembly level, so she only needs to reserve the top level for write access. So she's going to reserve it. She adds the fastener kit and saves it to the cloud, so any other users will be able to see her latest updates. Next, she lays out a 2D drawing with a bill of material that Megan will need to show the customer. Meanwhile, Eric gets to work on the stability problem. The issue management app keeps track of his progress and carries along all the information he needs to get to work. He starts by opening the attached 3D markup. He sees Megan's notes and clicks through the 3D geometry to find the affected subassembly. Megan attached the roller assembly, but Eric needs to reference its parent assembly as well. He locates it through the Relations app and attaches it to the issue. From here, he can open it directly into his SOLIDWORKS session. But this is where it gets interesting, because this is the same assembly Debbie is already working on. But that's okay. Eric only needs write access to the real roller assembly itself. The top assembly is just for visual reference. So he reserves what he needs to get to work, adding a stabilizing member. When he tries to save the assembly, he sees there are subcomponents that are also needed saved that he didn't reserve. So on the fly, the software gives write access to those additional files without causing an interruption to Eric's workflow. The save is complete, and now the assembly is up to date and safely uploaded to the cloud. Problem solved. Eric moves the issue status to in approval for Megan to review. Since Debbie is still working in the assembly, Eric needs to let her know he's finished with making changes. So he uses the built-in Conversations tool to send her an instant message. So what does Debbie do? Debbie just needs to refresh that assembly to get the latest version from the server. And she's up to date, including the drawing, which is now ready to be saved as well. To close the loop, she returns to her collaborative task, attaches the drawing, and leaves a comment to notify Megan and move the task to complete it, all without leaving her SOLIDWORKS design session. Now, back to Megan. One way she keeps up to date with her team is through her notifications panel. Anytime there's a status change, an update or comment on anything she's involved with, it shows up here. First, she checks on the issue she assigned to Eric. Her original 3D markup automatically shows the latest design changes. Everything looks good. So she marks the issue as completed. Issue management on the 3D Experience platform turns out to be a great way for Megan's company to log the history of problem reports and change requests, a must for their highly regulated industry. Now, to take a look at Debbie's work, Megan switches to her Bookmarks app. There, the drawing she drags right into 3D Play Viewer. It's exactly what she needs to show the concept to the customer. She marks the drawing as released so it can be changed for the duration of the customer's approval process. Megan posts a quick comment to her original discussion thread to congratulate the team on finishing this stage of the project. Multiple designers accessing the same file simultaneously. We all know how tricky that can be with traditional file-based storage. Concurrent design with out-of-the-box PLM. But with SOLIDWORKS plus Innovia, concurrent design is easy because the PLM tools are ready to use out of the box. Users can tell right away who's working on what, so they can avoid common problems like permission issues, version mismatches, and accidental overwrites. And when there are changes, the various notification tools built into 3D Experience platform keeps everyone in the loop. Teams can design faster, together, with fewer errors, even when workers are remote. Now, more than ever, companies are looking for ways to centralize and secure their SOLIDWORKS desktop data in the cloud while streamlining collaboration and enabling error-free concurrent design. Well, Square Robot, SOLIDWORKS and Innovia made this a reality. Mr. Will O'Halloran, co-founder of Square Robot, stated, "Being a startup, you have to move fast. What was important to us was being able to remain collaborative because that's how we keep the speed up. With SOLIDWORKS, we have a cloud-based PLM solution that allows models to be shared over great distances and be synchronized instantly." In the story of Next Level Validation, you'll see how we've expanded your simulation-driven design capabilities and leveraged the best of both worlds. Industry-leading design tools from SOLIDWORKS integrating with industry-leading analysis tools from Simolia using best-in-class Abacus FEA technology. For this portion of the presentation, I will turn it over to Robbie Hoyler. Robbie?
Thank you, Warren. I'm going to go ahead and make myself the presenter. Actually, you might have to pass that over to me. There we go. There we go. Warren, are you able to see my screen okay?
Roger that.
All right, we'll go ahead and get started. So, discovering the product performance issues early in the design phase not only increase your bottom line as a company by avoiding costly rework, but it empowers you as a designer, engineer, or analyst to make a better product. Figuring out the best design takes multiple iterations and the ability to rapidly test various scenarios help you and your team make more informed decisions faster. Solving design challenges is one thing, but manufacturing the product is another. And being able to validate how your product is manufactured increases the value of your validation efforts. Let's follow a designer and a structural analyst to see how they collaborate and solve these various scenarios with this BioAdapt Moto knee. Debbie, the designer, is working on updating the mechanics of the Moto knee, a next-generation prosthetic designed to withstand the high impacts of action sports. From her company's dashboard, she sees that Adam, the analyst, found a mechanical issue with the first revision. Adam's simulation results can be viewed right from a web browser, and Debbie confirms that the lower bracket definitely needs to be redesigned based on Adam's findings. The simulation results tell Debbie where the changes need to be made, and she starts to design a new revision of that bracket. Proud of her work, she thinks her new design will now be strong enough, but before she sends her new design to Adam, she wants to validate it herself. The simulation apps in her structural designer role can guide her through all of the steps to validate the strength of her new design. The built-in assistant makes it easy for Debbie to add loads and fixtures and then run her analysis and review the results. So she can make that change on the fly and then update Adam. Feeling confident in the newer design, she updates the Moto knee assembly as a new revision. Both Adam and Debbie are working from the same dashboard, so Adam can see the new simulation and review it. Adam will also move forward validating the new assembly. So the designer is looking at one singular portion, and the analyst is looking at the assembly as a whole to validate. Since both the design and simulation data are stored and connected on the 3D Experience platform, Adam is able to easily create a new revision of the simulation he created earlier. After opening the new revision, he simply replaces the old model with the new one to reflect Debbie's changes. From there, he just needs to modify any fixtures, loads, and connections that associate with the new geometry and resolve the analysis. And just like Debbie, Adam also can use the assistant to make sure he doesn't miss anything before he runs the study. So all of the concurrent changes that Debbie has made get piled into the study that Adam is creating. With the results complete, Adam compares the two studies. He confirms the new moto knee lower bracket is now strong enough and no longer suffers from the excessive displacement of the earlier design. The assistant helps both designers and analysts run studies fast and evolve their designs quickly based on valuable simulation results. And creating and managing design validation information on the 3D Experience platform keeps you and your data connected so your team can stay productive. Adam was able to validate the strength of the new bracket, but how will this affect the rest of the assembly? Due to the harsh conditions of action sports, the moto knee is often subject to harmonic and random vibration loading. Furthermore, Biodapt created the moto knee to be adaptable to many different extreme environments, so there are multiple different configurations of the design. Each one is a customization for both the field for the wearer and it's based around the sport they are competing in. So anytime a change is made, every single configuration needs to be validated for each extreme loading condition. So you have dozens upon dozens of validations that have to occur. Similar to the creation of a linear structural validation, Adam is able to create a frequency scenario with the apps provided in his structural performance engineer role. He uses the assistant to complete all the necessary steps. After solving, Adam is relieved that most of the natural frequencies of this configuration of the moto knee are outside the expected operating region. To better understand the remaining vibration concerns, Adam creates a random vibration scenario using the structural mechanics engineer role. This role expands the type of physics that can be addressed and the types of studies that can be solved. Conveniently, the new scenarios are stored in the same simulation project as the previous results, and he can see that the performance of this configuration is acceptable. Now that he has both the natural frequency and random vibration studies completed for one configuration, he can easily repurpose this study and solve additional moto knee configurations at another time. For now, he's going to move on with his next task in the validation of this design. Adam now needs to understand how the different configurations of the moto knee will perform under different dynamic loading environments. Swapping out the guide plates of the moto knee will change the response of the knee under load. So Adam creates an explicit dynamic study that includes a prescribed rotation and adds sensors to calculate the required torque to achieve that rotation. Adam also needs to understand the force feedback felt by the wearer to ensure comfort and performance. After solving one iteration, Adam makes a quick change to the plates in SOLIDWORKS and updates the model in his study. Only the change parts need to be remeshed, which is done automatically by a simple update. Furthermore, Adam continues real-world testing and modifies the spring and damper properties of the shock. The moto knee is designed to be configured quickly by each user, and going through this battery of studies ensures that the wearer of the moto knee will be able to adapt their prosthetic on the fly for maximum performance and flexibility. The structural performance engineer and structural mechanics engineer roles on the 3D Experience platform enabled Adam to validate various configurations, use cases, and loading environments of the Moto Knee to better understand and communicate its performance in the real world. Without the cost of manufacturing or testing a single prototype, Biodapt was already evolved past this first design, ensuring that physical testing will be a quick and painless step in the engineering design process, because you can iterate infinite numbers of times digitally before you make that first single prototype. Based on his calculations, Adam determined that a deep draw steel foot cover would be the least expensive manufacturing method to create a strong cover that will protect the valuable components in the Biodapt VF2 foot. Deep draw manufacturing has a lot of variables, and retooling a punch or a die can be very expensive. So Adam wants to do everything he can to ensure he gets this design right the first time. By using conversations in 3D Swim, Adam asks Debbie to make him a model for the deep draw analysis. She's already on top of it and tells him where to find the model. Sorry about that, I skipped one slide. From his simulation app, Adam can open the model right away and creates a new study. His goal is to discover how close the resultant metal shape will be to the original design and figure out how much thinning will occur in the material and determine the minimum blank size to achieve that desired shape. Warren, can you guys still see my slide deck?
Roger that.
Okay, it was frozen on my screen for a second. So Adam makes quick work of setting up the properties and boundary conditions to simulate the manufacturing operation. Since he's using the explicit dynamic solver, the complex contacts and material behavior is solved quickly, even more fast than SOLIDWORKS simulation. Adam discovers that the thickness variation across the deformed shape is nominal, so now he moves on to optimizing the size of the blank. So take a look at that plot, guys. That's a pretty dense and quick mesh to run in the platform because you're using cloud-based technology to solve for that. That is a pretty complex simulation that you're seeing. To optimize the amount of material used for each foot cover produced, Adam makes another request to Debbie to make the modification. Debbie uses XDesign, the design app in the 3D Creator role, to make the appropriate modifications. Back in his simulation app, Adam updates the model and reruns the study. The results show that he's determined that the best stock size for the manufacturing operation is going to be this one. And he can save those results and catalog all of that for future designs. The 3D Experience platform not only delivers powerful technology for advanced simulations, it enables coworkers to thrive in a highly collaborative environment. When you're doing multiple design iterations back and forth and you need multiple people involved with the design decisions, the 3D Experience platform can be leveraged to really make that process extremely efficient. Simulia makes simulation-driven design more powerful than ever with assisted workflows and sophisticated virtual prototyping capabilities traditionally reserved for specialists, so you can reduce project risk and increase the chance of a launch success. Mike Schultz says, we can check clearances and ranges of motion, we can simulate that, model a round range of travel, and run strength analyses to be as lightweight and as strong as possible. So Warren, I'm going to hand it back over to you so you can finish up our presentation this morning.
Okay, Robbie. Can you see my screen?
I can.
Well, as a designer, you've always required the most powerful and most expensive workstations on the market. But with more of the workforce working remotely than ever before, you need a more flexible environment. With the 3D Experience platform, you can design on the cloud with any device without sacrificing the performance and power required for you to stay productive no matter where you are. In this demonstration, you're going to see an entire design process on multiple components of a circular saw, from concept to manufacturing, entirely within a browser. We'll start with industrial design. Dan's our industrial designer, in charge of ergonomics and aesthetics. Don's a mechanical engineer who will prepare the model for manufacturing. Let's drop in on Dan as he shapes a grip handle with 3D Sculptor. New primitive with creased edges. Getting started is easy. Dan picks a cylinder and drops it directly on the origin. Since flat faces will be incorporated into his design, he can get a head start by clicking on Crease Edges option while placing the initial shape. Bounding box. With 3D Sculptor, Dan can freely push and pull the model into any shape imaginable. But most of the time, designs are required to fit within a specific boundary. Scale by distance applies a parametrically driven bounding box where he enters a series of dimensions and the shape snaps precisely to size. Select all using the Control-A keyboard shortcut. All vertices are selected at once. This makes translating an entire shape to a new position a breeze. Scale and multi-axis. To maintain a uniform aspect ratio while scaling this side face, Dan can hold the Alt key while dragging any of the scaling dots on the robot manipulator. This shortcut will generally scale in all 3 dimensions, but since this space was planar, it conveniently maintains its flatness. Ordered geometric set. Opening the door to many creative workflows, multiple sets of features can be created with a single physical product. In this case, Dan would like to propose various concepts of this grip by creating a new face set for each of his concepts. Copy and paste features. He can simply copy and paste features from one set to another. Each feature set can have unique color properties and display states. And by double-clicking the copied subdivision feature, Dan can get started on his first concept of the grip while leaving the original start shape intact. No zoom during view change. By utilizing the Alt plus drag scaling technique, Dan can wrap up this concept in no time. As views change, the area of focus stays centered on the screen. This allows Dan to check his edits from multiple angles without having to continually wrestle with zooming and panning. Share 3D model with 3D Swim. Finally, to collect feedback from the rest of his team, Dan can post the entire 3D model to a community directly from the design app. This streamlines the communication process, allowing teams to arrive at a perfect design faster than ever. Create complex shapes in an instant with ease. With the ability to create subdivisional models directly in a browser on any device, complex shapes have never been easier to create. Let's move on to mechanical design. It's now been turned over to Don, the mechanical engineer, to complete the design and prepare it for manufacturing with 3D Creator. Don will need to create the stem connecting the body to the circular saw. the grip handle. To start, Don can create a mounting flange with little effort by pre-selecting a face in the context of assembly. He can skip the sketch and extrude his first feature. Sketched ellipses include construction lines, making them easy to orient. For example, Don can snap the quadrants of the ellipse to the midpoints of external model edges, or he can also click on both the endpoints and the edge, opting to create the same relationship in the pop-up menu. These relations will fully define the sketch. While extruding the feature, a preview is displayed, making it easy to confirm the correct end condition has been applied. But on second thought, Don is underwhelmed with the resulting shape and would prefer a sleeker look. To accomplish this, he can roll the design back before the extruded feature to create a curved path. Starting with a 2-point spline, he can activate the spline handles to achieve full control over the curvature. Relationships can be applied to both ends of the spline, and the handles can be adjusted until it looks just right. Don rolls the model forward to edit the original extruded feature. Not only can an extruded feature be changed to an extruded cut, it can even be transformed into a revolve, or in this case, a sweep. It's called a super feature, and it provides an unprecedented level of flexibility as all references are maintained. Now, since this part will be injection molded, it is important to specify a parting line by activating the parting line option on the draft analysis tool. Don can pinpoint its exact location. After adding a few more features, Don has split the body into 2 halves. To make these bodies easier to work with, they can be divided into separate sets of features. This way, each set of features will be independent from each other. By hiding the other feature set, Don can also focus the lower half of his design. To lighten the design and prepare it for modeling, Don adds a 2mm shell feature. To reduce the hollow design, he can sketch a profile for the rib. Even without perfectly trimming or extending the sketch entities, the rib feature will project the geometry to fill the internal volume of the component if necessary. Draft could be applied at the natural plane or where it intersects the inside walls of the part. Design with precision, anywhere, at any time, on any device. Thanks to the flexible design workflows, design changes are nothing to be afraid of in 3D Creator. And with the visual insight provided within modes like draft analysis, Don can rest assured this part is ready to be sent to manufacturing. Having the right tools allows you to get to market faster and reduce costs. For example, the milled angle bracket and the base plate of this circular saw are not only expensive to manufacture, but also require additional assembly steps. Don recognizes this, so he decides to use 3D Sheet Metal Creator to consolidate these 2 components into one. On the 3D Experience platform, all applications are compatible with each other, with a seamless switch from XDesign to sheet metal. The toolbar in Don's user interface updates so he can stay focused on the task at hand. Don will start by isolating the components he plans to replace and creating the new replacement component. Copying the footprint from the original base will give Don a head start on the redesign. These holes are no longer necessary, so they can be removed. X sheet metal includes advanced context recognition, which means he'll have quick access to the tools he wants keeping his mouse cursor focused on the model. While getting started, he conveniently prompted to provide some overall sheet metal parameters to be used as the default values. Saving time on downstream features, Don hides the original base plate and he captured all he needs for this first feature. To enhance the design, he can bend this front edge upward so the base can smoothly glide over the workpieces. This position of the bend is precisely defined by the sketch line bend that can be set to any angle. Not all sheet metal features require a sketch. In this case, Don selects the outer edges of the base to add some short walls. There are multiple alignment options to perfectly position the add materials such as measurement, criteria, and material side. To confirm that the corners were trimmed per the default parameters. The current design can be flattened at any time. The new cost-effective design requires a flange that mimics the angle bracket. Using the intelligent context-sensitive menu, Don creates a rough clearance cut for it. Once again, he converts the profile from the previous design and makes some small adjustments. To strengthen the connection to the base plate, he'll remove these entities and close the gap by merging the endpoints. Even though this sketch was created out of plane, it can still be used to create a wall on edge feature. The default tangent relief set earlier may not apply here, but Don can override it on the fly for this unique instance. Finally, he wants to adjust the material side to ensure the flange doesn't interfere with other components. To account for manufacturability, Don can check for overlapping geometry in the flat pattern. With an overlap detected, he can measure the highlighted edges to assess how big of an adjustment needs to be made. By subtracting the necessary clearance directly within the dimension field, X sheet metal does the math and reduces the risk of entering the wrong value. Sharp edges could be dangerous to the end user and increase the difficulty to cut. So Don uses the corner tool to gather the edges and round them off. Another way Don can improve this design is by adding a guide rail. This will require a pair of clearance cuts through the sidewalls. Don starts with a rectangular sketch offset from the end face of the guide rail. By deselecting the link to thickness option in the cutout tool, the cut can be extended through the entire model. Of course, all of the cut faces will be created normal to each surface to allow for a conventional laser, plasma, or water jet cutting process. A slot needed to be created to hold the guide rail in place. In manufacturing, a feature like this will be stamped with a forming tool, and it can be modeled using the exact same technique. First, you'll have to find a tool using the 3D Experience platform's powerful search capabilities. Then he can define its location on the model with a sketch point. Finally, the user stamp feature allows him to specify the direction, fill the parameters, and which face to remove from the resulting geometry. To give his sheet metal component a realistic look, Don searches the extensive material database for a galvanized metal appearance and applies it to the part. These materials are perfect for making design reviews and engaging and also support downstream workflows such as product renderings. Don will supply his design to the cutting machine using the industry standard DXF format. This will include the cutting profile, bend lines, and user stamp. Saving it to the 3D drive allows him to share the file with anyone so they can view it and add markups using the 3D Play app. Additionally, these markups can be shared to a community to notify key project stakeholders and discuss further changes. Before closing his browser for the day, Don notices another component that will require a flat pattern before it can be manufactured. Unfortunately, this component was created using traditional modeling features like extrudes and cuts. Still, Don's able to get the information he needs using the recognized tool to calculate the accurate flat pattern. Develop sheet metal parts ready to be cut and bent. When you use the right tool, you can get your job done faster at a higher quality. The 3D Sheet Metal Creator role on the 3D Experience platform provides a purpose-built environment that will have your designs ready for manufacturing in no time. A team of engineers have been busy evolving the aesthetics of the circular saw, along with finding ways to reduce manufacturing costs through creative sheet metal design. But before it can go to manufacturing, material finish and color selections have to be decided on. Let's see how you can help accelerate the decision process and get this product to market with the powerful cloud rendering capabilities of the 3D Experience. Dan is working in the 3D render role in order to kick off some product color proposals, creating a new rendering project. He has instant access to all the current design data through the 3D Experience. Being new to this role, Dan immediately notices the lean user interface, which makes it easy to start creating some photorealistic renderings right away. A handful of components in the circular saw already have appearances that were applied during the design phase. And since these are retained in the rendering project, Dan can dive right into making a color modification. Creating a new scene lets Dan modify the appearances while maintaining the original, changing red to blue for the housing, and the light gray on the blade guard, at any point, Dan can enable the rendering preview to check in on his progress. This is a perfect way to verify materials and color selections are just right before moving to the final render. Simple camera settings can also be modified on the fly, and Dan decides that a 35mm wide lens and modern 16:19 aspect ratio looks best. Now it's time to render the project. Simple output options lets Dan adjust his image to start the HD resolution and high quality setting. The necessary credits that will be consumed for this rendering job are calculated and displayed. These credits provide a scalable option that are calculated based on the project needs. With click of the mouse, the 3D Experience takes over by rendering this image right on the cloud. Returning back to the original variation, Dan will generate another rendering which can be done while the first image is being processed. This time, An interactive turntable will be used to extend a virtual walk-around to the rest of the team. The job is submitted and run side by side with his earlier requests. 3D Render allows endless rendering processes to be done in parallel, never slowing Dan down from tackling his next task. After only a few minutes, each rendering is complete and are ready to be shared. Dan has the option to download these locally, save to the 3D experience, or directly post them to the team's collaborative swim community, where everyone can view, comment, and finalize their decision. Now that the customer colors have been decided on, Dan's next task is to generate some marketing assets. 3D Render supports complex materials as well. These physical-based representations of the saw blade will add the extra detail for the final output. A quick search, drag and drop, and the custom materials is applied. A glimpse of the preview window, and Dan gets instant feedback on his material selection. Other 3D design assets can be repurposed and add into a 3D render. Searching the team's design library shows a woodworking table. Dan drags this in and positions them, both the table and the saw, for the final output. Applying an ambience to the background adds a nice final touch. Just a few tweaks to the background size, exposure, and adjusting the camera perspective to get the perfect shot, Dan is once again ready to send another project to the cloud using 4K resolution with ultra-high quality rendering options. This image will be approved for publication in no time. Offload your rendering tasks to the cloud. Whether you're creating quick renderings for internal design reviews or generating professional level marketing assets, 3D Render on the 3D Experience provides an easy, affordable, and scalable option for all users on any device. SOLIDWORKS Cloud Design Apps introduces new capabilities with easy release that provides more mobility without sacrificing the power design tools you know and love. Subdivision modeling captures your best creativity as you create organic and ergonomic shapes, saving hours on design time. Familiar tools that every mechanical or sheet metal designer is familiar with allows you to feel right at home. Cloud-based rendering helps bring your work to life without having to worry about hardware constraints. All of this functionality extends to you to design on your own time as you work wherever on any device. Check out our 3D Experience Exploration page. The team has posted bi-weekly webinars into the next year, and a lot of demo videos to check out. In select countries, we also have a 7-day trials available, so you can request one on the same landing page. So make note of this site, solidworks.com/lp/exploring-3D experience-works-live. In the second act of Works, What's New, you saw in-depth demos of how 3D Experience extends the work you do in SOLIDWORKS today. It's really exciting technology. Using Novia for cloud-based collaboration, Simolia for high-end physical simulation, SOLIDWORKS for cloud-based X apps. Now, what do you want to explore next? In the preceding program, you saw the power of SOLIDWORKS R&D multiplied by the immense talent across broader Dassault Systems R&D. SOLIDWORKS is the heart of the 3D Experience Works portfolio, and 3D Experience Works is your entry to the Dassault Systems cloud-based platform. Each of these tools are designed for you to streamline collaboration, data management, simulation, design, and even extend into further domains such as manufacturing, governance, sales, and marketing. You'll see more about 3D Experience Works soon. In the meantime, enjoy SOLIDWORKS 2021. So this time we want to open it up for some questions. So Robbie, if you can, help me with this here, see if we have any questions from any of the audience.
I took a couple of simulation questions down. The first one that was asked, are there any CFD tools on the platform? Yes, they are launching a CFD tool. I believe with the next FD release, there might even be a partial release up right now on the platform. But yes, CFD is definitely coming to the platform. The next question was, how are these tools comparable to SOLIDWORKS simulation? In many regards, some of the studies that you can run on the platform actually run faster and are more powerful on the platform. There are a lot of tools, especially on the nonlinear side, that are actually extremely fast on the platform because you could utilize cloud computing and you use cloud credits to do that. One of the biggest limitations to being on the desktop is the hardware that you're running on. With the cloud, you're going to get a lot more bang for your buck. You can buy cloud credits and do that, and they're fairly affordable, much more affordable than say buying a simulation machine or speccing out a multi-$1,000 simulation machine of the same stats. And just to kind of put it into perspective, like we have one cloud machine on our platform that has 8 processors, 256 gigabytes of RAM, and a bunch of other stuff, and I think it costs like 67 cents an hour to run that machine, so it's extremely affordable. I think that was all the simulation questions I had.
Actually, Robbie, I think I have one here dealing with the 3D Experience platform. This user asks, does SOLIDWORKS desktop run over the cloud? Well, the answer to that is no. SOLIDWORKS actually still runs locally on your desktop. But what it does, XDesign and Xshape does run over the cloud. So you connect to the cloud from SOLIDWORKS with a connector, or if it's installed with the SOLIDWORKS Connected app, then installed from a browser and assigned to the user. So SOLIDWORKS still runs on your local machine. You still need to meet the minimum machine requirements, but it is not running over the cloud. It is connected to the cloud and allows you to upload your documents and store them locally as well. Hopefully that answers your question.
And to clarify that even a little bit more, the standalone SOLIDWORKS seat that you might own will run on the UES or SOLIDWORKS Connected role. And the 3D Experience SOLIDWORKS, the licensing is handled on the cloud, so you just need that installation from the web browser, and it's actually a really short installation. It's like downloading from the web browser to get access to that. So that's a pretty powerful one.
I think I see another question here. Which prototype companies do you work with in manufacturing your designs?
So
prototype company. Well, that's
you mean
kind of
like rapid prototyping, like 3D printing?
I think that's what Pat's alluding to. He could be talking about, he says, can we move PDM Vault to the cloud? That's from Eric. The first question, which prototype companies do you work with in manufacturing or design? I guess that's up to the user. They can work with a variety of 3D printing facilities. TPM, we also offer 3D printing manufacturing capabilities. And you can also work with machine shops as well to create prototypes and manufacture products for your design.
TPM actually specializes in two types of prototyping there, Markforged and HP technologies specifically.
Yes. And this next question, can we move PDM to the vault? Can we move PDM Vault to the cloud? Well, right now, we don't have a migrating tool that will automatically migrate your vault into the vault at this time. But that doesn't mean it won't be coming soon. But the answer to that question right now, today, is no. Are there any other questions anyone would like to submit? Okay. So with that, we'll go ahead to the next here and start with the rest of the presentation. The next session will start at 10 a.m. Session 6, Design Automation. So please take a break, go to the restroom, grab a coffee, answer a couple emails, and we'll be here waiting for you to return. Thank you so much for joining our session, and stay tuned for Session 6, Design Automation.
Thanks, everyone.